Okay, so we're going to look at the standard equation of a parabola. And so the first thing I want to do is develop some intuition for this because it can also help with ellipses and hyperbolas if you're going to study those as well. So the first thing is you could have a vertical parabola. A vertical parabola. That means it opens up or it opens down, one of those two. Okay? The thing about vertical parabolas is they have symmetry left to right. You know, there's a mirror image of every point if you go left to right. So these have left to right symmetry. And what that tells us about the equation of a graph is that it has x squared because it's got symmetry left to right. That means x is going to be squared in this particular case. It could also mean x is to the fourth or x is to the sixth, etc. But x is squared. You do not have top to bottom symmetry. So no top to bottom symmetry. So that means y is not squared. Okay? And so the equation for a vertical parabola, the standard equation for a vertical parabola looks like this. You're going to have x plus or minus some unknown number squared equals another unknown number times y plus or minus some unknown number. Okay? Now don't overcomplicate this. I know it looks complicated, but the idea is that x is squared and the squared part's by itself. The other thing is you notice that you've got x plus or minus in parentheses and y plus or minus in parentheses. So that's huge. If you can recognize that, then the only thing left to have is the squared part by itself. This side, since it may not be, the y part may not be by itself, may be multiplied by some number. Okay? Let's look at a horizontal parabola, and do the same analysis. A horizontal parabola lies on its side, so it could open left or it could open to the right, okay? And both of these have symmetry from the top to the bottom, up and down symmetry. Which means that the equation will have y squared. Furthermore, they do not have symmetry left to right. So there's no left to right symmetry. Which means that x is not squared. Okay? X is not squared. So, if we look at that, a horizontal parabola, y is squared. So the equation is going to be very similar to the one we looked at above, except now it's going to be y plus or minus an unknown number squared equals an unknown number times an x that's not squared. So this is the equation of a horizontal parabola. Now, don't memorize these. Think about the symmetry, because the symmetry ideas apply to ellipses and hyperbolas as well. Ellipses and hyperbola have both types of symmetry, which means both variables will be squared. For parabolas, only one variable is squared. So one variable squared, and the squared part is isolated. Now, let's look at these equations one more time and understand what the unknown numbers represent. In both cases, what's in the parentheses, the two unknown numbers in the parentheses with x and y, well, since they're next to x and y, they give you an ordered pair. And in fact, that ordered pair is going to be the vertex. Now we'll have to see how they give you the vertex, but they give you the vertex in either case. Okay, which is a key part of a parabola. Then the other unknown number, the one that's multiplied by the part that's not squared, gives you the focal diameter. So that number is your focal diameter. And that's all there is to it. Because once you know your focal diameter, we can divide the focal diameter by 4 to get P. And P is crucial because P tells us how far the focus is from the vertex. Okay? So let's do a couple examples just to quickly get the vertex and focal diameter and some other things about these types of equations. Okay, so here's an example of a parabola in standard form. So we know it's in standard form for a parabola because the squared part is isolated. It's by itself on the left. The squared part is isolated, and we only have one squared part. Only one squared variable. In fact, y is squared. So y is squared tells us something about this parabola. It tells us we have symmetry like this, which tells us that the parabola opens to the left or to the right. Okay? Now, since this 9, this number here is negative, that's what tells you that it opens in the positive direction or the negative direction. So since negative 9 is negative, it opens in the negative direction. Now out of these two, we tend to say that the one that opens left is negative direction and one that opens to the right is the positive direction. So that means that this is the guy we're looking at. So we're looking at a parabola that opens left, okay? And that's one of the things we needed, the opening direction of the parabola. We established what type of symmetry, then we could see that it lays on its side. It's a horizontal parabola. And then since this number is negative, we pick the one that opens negative. So this one opens left. Now let's work further. Let's figure out our vertex. Remember, the vertex comes from what's next to x and what's next to y. Now the way to do this is the vertex has this interesting property where it makes the whole equation 0. So what we do is we take the y plus 2 and the x minus 5 and we figure out what y and x values make those equal 0. So if I solve this for y, I get negative 2, and if I solve this for x, I get positive 5. So the vertex is the ordered pair where x is 5 and y is negative 2. So there's our vertex. Okay. Next we have our focal diameter. The focal diameter comes from, sorry, let me highlight this stuff. The focal diameter comes from this number here. So our focal diameter is just 9. That's all there is to it. Focal diameter, I wouldn't care in my class on homework or test or something if you put negative 9, but a focal diameter is a width. Remember how wide a parabola is. So it's usually a number, and it should be positive since it's a width, and that's our focal diameter. It's 9. Now our p-value, we need to determine the p-value. Remember, the focal diameter is 4 times as big as the p-value. So if I know the focal diameter, I need to get my p-value, which is smaller. I take 9 and I divide it by 4. And there's lots of ways to write this. You could say it's 9/4 is a fraction. You could say it's 2 1/4. You could say it's 2.25. Those are all perfectly fine, okay? The last two might be better if you're actually graphing because it's easier to measure 2 1/4 than maybe 9/4, okay? So that's how you determine your vertex, focal diameter, P, and the opening direction from an equation in standard form. We'll do one more example. Now, I wanted to do something that looks a bit strange, but is also pretty simple. What we need here is we want this to be in standard form, and we notice that x is squared. So the goal for our standard form, because this is not in standard form, our goal is going to be the x squared by itself equals a number times the y that's not squared. Okay, so that's what we're looking for. So what we're going to do is get x squared by itself. So I'll add y, I'll add 2, so I get x squared equals y plus 2. So we're close now. At least the squared part's by itself. So what I want to do is be able to think of this like this. So if I want x plus or minus something, well, the best way to do that is to do x plus 0, because x is the same thing as x plus 0, and that's squared, equals. Over here, I need a number times y plus or minus something. And so I notice that y has a 1 in the front of it. So what I'll do is I'll factor out that 1. And when I do that, I pull the 1 out, and that leaves behind, if I factor out a 1 or divide by a 1, I still get y. And if I divide by a 1 here, I still get plus 2. So we never really factor 1 out, but we need it to look like this because this number is going to be our focal diameter. So in this case, that's our 1, okay? So now we've got our standard form. So we can get our vertex. Let's start with our vertex. I look at x plus 0, and I look at y plus 2, remember? And I figure out what makes those each equal 0. Well, clearly x is 0 here, and y is negative 2 here. So our vertex is the ordered pair where x is 0 and y is negative 2. Then we have our focal diameter. The focal diameter is 1. That's just this number here. P is, take our focal diameter and divide by 4. So P is 1/4 or 0.25, okay? The only thing we have left to do is determine the opening direction. So we know the x is squared. So that means that it has symmetry this way, which means that we're looking at a parabola that opens up or down. And since the 1 is positive, that means we're going to open in the positive direction, which is up. So it opens up out of those two. Okay, so that was another quick example on some analysis of the standard equation for a parabola.